measures of variation. This is not our worksheet, this is just an example. So let's say we're very interested in buying a car. The price is really important. And price is related to miles per gallon, so we look at a couple of different types of cars and we say, well, we're going to buy one of these two types of cars, and we figure out that the mean miles per gallon of one car that we're very interested in is 22.3 miles per gallon. Now I say mean, that indicates that the manufacturer or somebody took a sample of that, or maybe 50 cars, and they did miles per gallon, and the average of 50 cars miles per gallon. That makes sense to everybody? And that's what we learned last time. That's a measure of center. We're also considering another car. That car, it turns out, gets gas mileage of 24 miles per gallon, and the number 24 was obtained in the same manner. Maybe the 50 cars were sampled, and they averaged the miles per gallon of the 50 cars, and they got 24 for this. That makes sense, everybody? So which car are we buying? You're going to both the same price? 24?
Depends on money.
Well, let's assume everything is equal except the miles per gallon this one. In other words, the cost is the same. I mean, we don't have any affinity to one or the other. We'll probably go for the 24 because miles per gallon are important to us. They use the same type of the same type of gas, and so we go for 24. And that's a good decision. But as a student of statistics, you should have asked the question. You should have said, you know, when they did the test, and they had 50 cars each, how much variation was there in the miles per gallon when we tested the 50 cars? Were they all right around 24, or were they all spread out a lot? And let's assume for a second that when they tested the black car, that the distribution of miles per gallon was very consistent. And it was really right around 22.3. So all of the model cars, the sample cars, they were fairly consistent. But you find out, as an astute consumer and a statistical person, that when they did the 24, they were really erratic. There was a lot of variation, okay, in these cars. In fact, their distribution looked like this. Well, I guess I got to make the high point at 24. That would be bad. They were wildly spread out. They had cars that got really poor gas mileage, and some got really good mileage. But the average, the center, was 24 miles a gallon. Make sense? So now which car you want to pick? It's up to you. You know, the average was 24. That's higher than 22.3. And maybe you're lucky. Maybe you get some car that is just wildly, you know, efficient. And in the green curve, there's a lot of them above 24. But maybe it's a bad day for you to get a lemon. Because this sample yielded lots of variation. The black car had not as much variation, more consistent. Does that make sense to everybody? And so that's why these two numbers, this idea of the middle and how spread out you are, okay, are both really, really important. And so we're going to talk tonight about this idea of measures of variation, which is about how much the data varies. And it's really important because, you know, I hardly ever see anything that they tell you how much the data varies. You talk about, they give you the averages, they give you the medians, but they don't tell you anything about how much the data is spread out or it varies. And it's really important. the information in. All right, so we're talking about measures of variation. The first and the easiest measure of variation